Hello everyone and welcome back to a new video. This video is about just like a hands-on kind of tutorial about how do we build an actual logistic regression model using Python as a programming language. So we talked about last time what is logistic regression and then how do we build a logistic regression model and what are the use cases of building a logistic regression over maybe a linear regression because those two are supervised learning models, but those are solving different kind of issues. Like the main difference between linear regression and logistic regression is just basically for linear regression. Uh, it's predicting numerical values, like predicting the price of a Toyota next year, what would be the average price of a 2026 or 2027 Toyota Avalon. The price could be like anything from zero to like, I don't know, $1 million. So it could be like any value. If for logistic regression, we're still predicting, but the variable, the target variable that we're predicting, it's usually categorical. So it takes values that are very limited, maybe sometimes two, which is a binary logistic regression, sometimes three, four, five, but it's usually the set of value that the target variable that we're trying to predict is usually very limited to, I don't know, it's usually on average less than five, but you could end up having a logistic regression where you're predicting from something with more than six options, but usually it's less than five values. But that's usually what the logistic regression is about. What do we do the first time is always finding a good data set. And as I was telling you guys, I have a video about building, finding your own data set on Kaggle, which is a platform where like data scientists, data analysts, ML engineers are collaborating together to create some really good um, open source content. So there's so many good data sets there for different use cases. So just go check it out. Kaggle. I found my data set on Kaggle, so this is where I will be building my logistic regression model. And it's just about um when you apply when anyone is applying for a loan, what determines if that person will be approved or rejected. I choose that topic because whenever you're in school, you often apply for like a student loan to kind of help um finance your studies for 4 or 5 years because you don't have at that time enough money to pay out of pocket. So usually a student loan is something that helps a lot of students. But if you get lucky to get free education, that's fine too. I mean, that's perfect. But like a lot of students have to apply for students loan, which when they apply, it's not guaranteed that they will get approved or rejected. So this is why I kind of chose this. So what are driving factors and how do we predict if somebody's loan application will get approved or rejected. And actually, so many loan companies are actually using machine learning models to predict the outcome of a student's loan or maybe any other type of loan. So usually when you apply for a loan and you send your application to that platform, they have their own machine learning model that is reviewing your data, and then just based on the machine learning model that they build, it will give like an output immediately to the loan application person that is taking charge of giving the loan or not. So just based on the outcome of the model, the person is going to just sending an email to the applicant saying, "Oh, you know what? Your loan was rejected or approved just based on these criteria, da 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 da." Da." And usually those criteria do not come directly from a human person. It usually comes from a model that they built before, and then the human person is just like double checking the output of the model, which is pretty powerful. So when we have our data set, it's about loan application. And then the first thing that we do is always to load our data, you know, what is data about? How many rows, how many columns does the data have? And then once we load our data, we usually want to kind of have like a sense of like what the data looks like by using the function head in Python. So that will help us get like an overview of what the data is about. Here we probably have like identification 0, 1, 2, 3, 4, which is probably like instances of people that apply for a loan in that particular data set, and those are information about those people. How many people, the number of dependent, which is probably the number of children of that person, the education level of that person, if that person is employed or not, the annual income of that person, the loan amount, how much they actually want to loan, how much they actually want to get from that loan company, and then the loan term, which is actually how long are they going to reimburse the money that they are loaning that from that company? So that they are borrowing from that company. So that's something like that. And then we have a lot more other attributes here. And then in the end, we have this loan status, which is approved or rejected, which is actually the target variable here. So once we have an overview of what the data looks like, we kind of pretty much do the same process as the linear regression, and then we start cleaning the data. So I realized when I was cleaning this data that some of the attributes naming are named this way. There's like a space and then the attribute name, space and the attribute name. We don't want that because sometimes you might want to like get some like details about this type of attribute, and then when you call that function, and then you would just use this attribute name because this is what you know, and then it's going to give you like an error because the attribute name in the data set actually has some empty space before the actual name of the attribute. So we want to get rid of that. This is why I kind of got rid of that. If you want to ask me how I found that some of the attributes have like space between the name of the attribute, it's just by looking at the data and looking at some of their description of the data. So this is why doing some basic description, doing some basic overview of the data is very helpful this time. And then once I clean my data, there was also no missing values. I always check missing values and outliers just in case you don't want to kind of bias your data towards certain type of um, outcome. So just double check if there are any missing values, any outliers, and then if they're missing values, kind of remove them. If they're outliers, find a way to handle those outliers. But luckily, we had such a clean data set, we didn't have any of those things, so that was nice. And then the next thing will just be to understand what is the relationship between the target variable, which is in this case the loan starters here, and then some of the other attributes we have, maybe the number of dependent and everything. So the idea will be to understand if maybe, I don't know, the annual income influences the loan application status. That means, does that help if the annual income of the person is higher? Maybe that will help, or that will increase the chances that the person will get the loan approved compared to someone who is earning a lot less than them. So this is why I had this sort of like exploratory data analysis step where I'm just sort of like understanding what is the relationship between the target variable and other and the descriptive variable in the data set. So for instance, I kind of displayed a plot between the loan status and every other attribute that we have in the data. And then I kind of did it for every single variable. You don't have to do it, but the goal was to understand which variable are actually the most significant when it comes to like giving a loan, approving a loan, or rejecting the loan of a person. And then after comparing numerical variable and the target variable that we have, I found out that the credit score and then the loan term are two of the most important factors that determine if someone is going to get their loan application approved or rejected. Just because the higher your credit score is, the higher the chances are that the loan company we assume that you will pay back the money because that is the definition of a high credit score. A high credit score means you usually pay back whatever debt you have on time, which is very important for those type of company. And then long term is maybe they don't want someone who gets a loan and then they pay in 5 years. Maybe they want that money in such a short time. So maybe the loan term is like the longer your loan term is, maybe the less likely you have to get the loan approved, which is the reason why we always need to do those sort of visualization. It's pretty important. And It's actually a very good way to show your work if you are presenting to someone like some stakeholder or to your manager or whatever. And then I kind of do the same with other categorical variables as well. And then I found out that being at least a having like a graduate like higher level of education like a master's degree or a doctoral degree does not necessarily means that you get your loan approved compared to someone who maybe has like a high school degree. So education level does not matter here. Yeah, that's pretty much what I did. And then before building the model, so the reason why I was doing that is sometimes when we're building the model, we don't want to use every single variable we have in a data set, because that will be overfitting the model. Sometimes we just want to use out of those maybe like 15 variable, exploratory variable that we have, what are the top maybe three, four, five that explain the most the outcome of a loan application, and then we kind of build the logistic model just using those five attributes instead of using all the 13 attributes in the model. It helps only focusing on what matters the most and also letting the model think, like kind of find patterns on its own instead of overfitting the model for no reason. So this is why we're also doing this visualization, kind of reducing the data size that we're using for the model building. And then because we're talking about a credit score, we're probably going to use that for the model. We're talking about um, the long term, we're probably going to use that to build the models as well. So those are some of the things that we'll be using. We're not going to use everything for sure, because not everything is significantly important when predicting loan application status. Yeah, and then the last thing that I want to talk about is in the data set, we need to do one feature engineering step. Feature engineering is usually kind of transforming some of the variable to something that would make sense for the model. So we need to do one last feature engineering step. So that step would consist of, so you can see here that the loan status, which is the target variable, so we need that for the model, but it's using text data, approved, rejected, rejected, approved. However, the model does not understand anything that is not numerical. So if anything does not have like 0, 1, 2, 3, or anything that is not numerical value has to be transformed before feeding that information into the model. So this is why we are going to apply some feature engineering step instead of like transforming this variable into something that will make sense for the model. And in this case, we just use like 0, 1. So anytime it's approved, we give the value of 1, and every time it's rejected, we give a value of 0. So once you build a model, and then you're predicting the next outcome, and then if the next outcome value is 0, you know that the loan was rejected. If it's 1, you know that the loan was approved. So keep that in mind when you build your model. The model does not understand anything that is not numerical. And yeah, so this is pretty much what I did here when it comes to the feature engineering step here. And then after that, I was ready to build the model. And then also we kind of make good use of some inbuilt library of functions that are already in Python in the sklearn module. So we have all those functions that are used to build a logistic regression model, so we don't have to do anything extra. So I will send this file in the link below so you guys can just copy that and then try it on your own at home. And then again, as we're talking about, we're only using those two variables to create model, and then we are building our models. And remember that when we're building a model, we need to split our data into training and test. The training set will be used by the model to sort of like understand why a loan is approved and the loan is rejected. And the test set will be used to test the performance of the model that we just built. We need to make sure that the model that we build is able to be scaled for feature loan applications. When someone is applying for a loan, maybe tomorrow or next week, we can use our model to predict with a high accuracy. And yeah, with the high accuracy, so every time we are training the model, we're kind of checking the training accuracy, but it's not enough. We also need to check the test accuracy, and we need to make sure that the test accuracy is as high as the training accuracy. even if it's not higher. So we want the training accuracy and the test accuracy to be around the same range, just to make sure that we're not overfitting the model, and we're also having a good accuracy so the model is reliable for future use. Yeah, so the accuracy is our evaluation metric here. We also have other metrics that we mentioned, the precision and the recall that are just supporting the accuracy. But in this specific case, when the accuracy is high enough, you know that your model is pretty good, and then you can move that into production and use it in real life or a real life situation, like student loan application. When you buy a house, maybe you need a loan for like a down payment. So everything like that helps. And yeah, this is what we built. We built our logistic regression model, and it's pretty much what we needed to continue the steps. So thank you for watching. And if you have any questions, let me know and see you next time. See you.